Hello, welcome back to our discussion. Today we're going to learn about volume of a frustrum. Feel welcomed and relax. Now, the volume of a frustrum, we find that is a part of a cone. A frustrum is a part of a cone that is left on the top part of the cone is cut. Now, in this particular figure, you can see it's a cone. In this particular second figure, we have this origin of corn, but we have cut the top part of it. Whenever we cut the top part of it of a corn, and then we're going to have what we call a frustum. Yeah, a frustum is going to have the bigger radius, and then we have the small radius, and then we have this particular height. The volume of a frustrum is equals to a third pi r squared h. Now, for example, when we say a third pi r squared h, we mean that here we can have the radius, and then we can have here the height, and then we can use a third pi r. Now, a third pi r squared, this a third is from how many cones can fit exactly into a cylinder. We find that there are three cones. Now, when you take one cone, it is a third of that cone pi r squared h. Now, let's go down. Calculate the volume of the frustum below. For the given frustum that we have the this particular circle, and we have also another circle here. So we have the slant height, then we have this particular height. Now, how do we calculate the volume of the frustum? Now, think with me. The volume of a frustum, we just say the volume of a frustum is a third pi r squared. This particular r is for the bigger radius, and height is the height of the original cone, minus a third pi r squared h. A third pi r squared h, this volume is the volume of which for us to get the volume of which top part of that cone when it was cut, like this one, this volume is what we call a third pi r squared h. Now, so it means that this particular formula, it matches to the volume of the top part, and then the volume of the first one, a third pi r squared h, this one is equals to the volume of this particular cone, original cone. Now let's go and calculate that volume of that particular cone. Now, what you do, extract a right angled triangle of this particular kind. So we have the original height, and then we have the small height. We have the radius 2 centimeters. We have the height 3.6, and then we have the top radius 0.8 centimeters. Now let's go to the other side. How can we find the original height? The original height, the bigger height that we want to find, we're going to use similarity and enlargement concepts. We are going to say that this 2 over 0.8 is equals to height, this height plus the height that we have here, 3.6, over the small height, so that we can be able to get the original height there from the concepts of similarity and enlargement. So whenever you do like 2 height is equals to, you close multiply here, and then for us to calculate this now small height, we find it's 2.4. How can we get the original height? So it is 2.4, this small height, plus 3.6, so that we can get the height from here up to there. So that's why you have added and found 6 centimeters. Now let's go and do that question. So volume is supposed to be a third pi r squared h minus a third pi r squared h. A third pi r squared, now we're going to use r2, and we use 6 for the original height, minus a third pi r squared, small radius, volume of the small part of the cone which was cut, times that particular height which we found here, 2.4 small height. So you can see the difference. you can have the original height 6, and the original height is from here up to up, and the small radius small height 2.4 from here up to up. Now whenever you do that particular multiplication and subtract, you get 23.536 cubic centimeters. Now let's go to method 2. Method 2, there's a formula says a third pi h into r squared plus r squared plus rr, which means a third times 2/7 times. Now you go to this particular cone, a third times 2/7 times 3.6, this one, into brackets we can have 2 squared, and then we can have 0.8 squared plus 0.8 times 2. So it brings the same answer. This one, that one comes the same answers by using method 1 and of this particular formula, and method 2 of this particular formula. Now, if you find this lesson helpful for you, subscribe for more mathematics lessons. Thank you for watching.